Hello, everyone. My name is Nia, and welcome to today's webinar. We'd like to give a we'd like to give everyone a minute to join and settle in, so please use the chat to let us know where you're tuning in from. I myself am tuning in from New York City, and we have Richmond, who's joining us from the UK, specifically in London. Make sure when you are responding in the chat, you're responding to everyone, because there may be someone in the same location as you. Someone from California on the West Coast, good morning to you. Sag Harbor in New York. From Canada. Love Canada. Denmark, India. For the people who are joining and it's a little bit later your time, thank you so much for joining at your hour, your time zone. Greetings from Switzerland. Welcome. Ooh, Bel Air, California. Atlanta, Washington, D.C., Germany, Israel, Arizona. If you're just joining, make sure you're dropping your location in chat. There may be someone tuning in from the same location as you. We're going to get started in just a second. We love having these global audiences. It makes it much more interesting in what you guys are interested in around the globe with our topics. Okay, it looks like we have a good amount of people, so I'm going to go ahead and get started. I'm happy to welcome you all to today's webinar, AI Database Comparison, MongoDB Atlas versus Elasticsearch. Today we have Richmond Alake, staff developer advocate here at MongoDB, who will be going through today's presentation and answering all your questions in the Q&A. But before we hop into the presentation, we're going to go over a couple of quick housekeeping notes. First, please note this webinar will be recorded and shared early next week, so please keep a lookout in your emails. All participants will be muted, so if you do have any questions, please drop them in the Q&A box. It is located at the bottom of your Zoom panel with the box and a question mark saying Q&A. The chat is for general discussion and live comments only. There will also be a short survey at the end, so we greatly appreciate your feedback if you fill that out. Now I'm going to hand this over to Richmond, who will begin today's presentation.
All right. Good afternoon, guys. It's afternoon over here in the UK. Thank you guys for joining us today as we explore the world of vector databases, AI databases, whatever you want to call it. Today, we're going to be exploring two solutions today, Elasticsearch and MongoDB, both popular solutions within the AI stack. And today, we're going to be looking at how vector search really works within this two solutions. So we're going to be looking at vector search in Elastic. We're going to be looking at vector search in MongoDB. We're also going to be talking about AI databases and what are AI databases and some of the key requirements of AI databases. Then we're going to be looking at some of the architecture that we've seen a lot of customers and developers leverage when they're building their AI application. So we're going to be talking about the split architecture and the unified architecture. We'll be talking about this later on. We're going to also talk about what it means to be asset compliant. And we see that as one of the key features for mission critical AI applications. So if you're building AI application that you expect your users to use within the finance industry, the healthcare industry, the legal industry, there are some aspects that you need to consider in terms of the documents that are stored in terms of audit trails, and also the fact that the documents are backed up and there are no loss of data or unexpected loss of data. So you can use the Q&A to ask any questions you have about databases, AI in general, and I'll be monitoring the Q&A and I'll also be asking questions as I go along. So we're all here to learn. So if you have any questions in terms of any information that you'd like to get clarity on, do share it. And one thing on the agenda as well is we're going to be looking at some of the challenges that we get in the split architecture. There's going to be code. And if you've been to my previous webinars, you expect a good balance between presentation, some images, visualization, and then code. And you'll be getting access to code later during halfway through this webinar. You'll be getting access to the code I'm presenting. And also, you get the opportunity to ask me questions. So use the Q&A channel. Okay, so the I always start with some foundation, just start with some foundation basis and concept. And there's gonna be a bunch of this. There's gonna be a bunch of this conversations, happening. So I want to start with some basic knowledge. So we started from LLM chatbots when tools like ChatGPT came out. But then we started to give this LLMs more domain specific, relevant data. And then that brought us into the realm of RAG. Now, the emerging abilities of LLMs is really improved in a very short amount of time. We have large language models that are able to conduct tool use or function calling. They're also able to have advanced reasoning capabilities that allows them to decompose a prompt into several different steps and execute the steps of the tools that they're made available to you. So this takes us within the realm of AI agents and agentic system. So these are the common patterns we're seeing today. But how we build this and what you're building with all the technology or solution is under the umbrella of the term the AI stack. So what you guys are building is using tools and components in the AI stack. And I define the AI stack as compositions of tools, solutions, and libraries that come together and integrate together to help build some of your AI products and your AI features. So at a high level, you can see the AI stack as the application layer, the tooling layer, the compute layer. But when I talk to developers like yourself, I double click into and I will talk about the programming language, the model provider using open or closed source models, the LLM orchestrators are using Llama Index, LangChain, Haystack, or you using LangGraph, Pydantic AI, small agents, or the operational vector database. What database are you using? Are you using 1, 2, 3, or multiple databases? Also, the monitoring and observability and deployment layer. So these are all the components of the AI stack. And it's important that we have an understanding of what we're doing and the tools that fit within the stack. But when it comes to database, the key thing you're looking at solving is information retrieval. So in all your RAG and agentic system, you're basically trying to give your agent or your LLM the most relevant information at a given time. And we've seen different ways that folks are retrieving information within the AI system. So common ways are full text, text search, vector search, and a combination of different search mechanisms, which you refer to as hybrid search. So the reason why I'm going for the basic is just to build up the foundation. It's just to set the foundation that we'll build upon and we'll take things into the realm of Elasticsearch and MongoDB and all the good stuff we're here for. So hybrid search allows you to use two or more different search mechanisms. So the common one are text search and vector search, but you can actually power your AI agents and RAG systems with different search mechanisms like geospatial search or geosearch, or you can also do provide data sources from REST APIs as well. MongoDB gives you capabilities to conduct the common searches. So MongoDB Atlas search and enables that lexical search feature. Then Atlas Vector Search allows you to search and retrieve and store efficient vector data. Then you have the MongoDB query language, which allows you to implement hybrid search stages and use the aggregation pipeline to execute this. So these are some of the common search mechanisms we see today. So MongoDB today, for those of you who are aware or new here, MongoDB is a data platform typically for your AI application. We provide not just a database, but other features that enables you to build AI applications that are successful in production and at scale. So for many RAG application, folks have used MongoDB to store vector data and operational data within the same database. We're going to be seeing that today. And for those of you that are more complex and advanced, building AI agents and agentic system, we typically describe MongoDB as that memory provider for AI agents. And then it clicks. So going over some of the basics, Atlas search or lexical search, how it works is you typically have a query, a keyword, and that keyword is sent from your application to your data layer. And the keyword is used to search against a bunch of documents within a bunch of attributes within your documents or multiple attributes. And then the returned results are documents that have the keywords within the attributes. Then you can send this back to your application layer. Then with vector search, we do something different. We take in the phrase or the sentence or the paragraph and we convert it into numerical representation that we refer to as embeddings. So these embeddings have captured the semantics and context within the data objects that we pass into it. In this case, this is this particular phrase. And when we convert it into this numerical representation, what you can do in MongoDB is use vector search to get similar, to get documents that have embeddings that are similar to the query vector. And that way you can actually power your RAG, semantic search, or recommendation engines and systems. If you have any questions, use the Q&A section and I'll get to them. Okay, hybrid search, combining both search mechanisms together will give you a functionality where you're retrieving results by similarity and then you're retrieving search results by keywords, but then you can combine them in the hybrid results that are usually ranked using some form of algorithm such as reciprocal rank fusion, and then you get like a re-ranked results and then you get the best of both worlds. Okay, so all of this is all great. And the common way that we've seen people implement all the functionality is through RAG, which is just supplementing your, augmenting the prompts you send to the LLM with relevant information so that you get relevant outputs from your RAG pipelines or your LLM systems. And speaking about RAG pipelines, what we have here is a typical flow of what a RAG system would look like. You have your data source, you prepare your data, then you convert your data into numerical representation, which are embeddings, and store your metadata and embedding in MongoDB. And then you can start to do things such as all the RAG functionalities that we're talking about. You're going to be seeing this today in code, and you're going to see in both how you implement that. You're going to see how to implement this in both using Elasticsearch and MongoDB. So if you're someone that use Elasticsearch, you're going to get some information and I might share with you some information that you didn't know or wasn't really, you might not have been aware of. But then I'll show you a better way of how you can build in this AI application. So MongoDB actually solves for different part of the RAG pipeline, the database section, but also we brought in Voyage AI into MongoDB to help use state-of-the-art embedding model to ensure that we're allowing our developers and customers to really build their AI application on a solid data foundation. So now you have MongoDB. Within MongoDB, you get state-of-the-art embedding models, you get state-of-the-art re-rankers, and you have your operational and vector database, basically a solid data foundation. So I'm just going over the basics for those of you that are just joined there. I'm going over some of the basic concepts I'm going to be covering in the code section today to make sure we're all on the same level playing field. Vector search. Vector search, we spoke about it several times in previous slides, but it's vector search, to give it a definition, is a computational operation that looks at the distance between two vectors or arrays or list, and then you compute the distance between them using some form of distance measure like cosine, Euclidean distance, or dot product. And the distance between two vectors usually represents the similarity of the two vectors to each other. So you have things such as cosine similarity and get a score like 0.72, with one being very similar. So that is vector search at a very high level. We're going to see it in action in two different data solutions. But semantic search, and a lot of people kind of conflate the two, vector search and semantic search. Vector search powers semantic search, and semantic search is really information retrieval method that is based on context and meaning. And within semantic search, you're using vector search to actually compute the distance. So this is what that looks like if visualized, right? You have like an input prompt such as show YouTube videos, and then you convert that into some vector, and then you do vector search and get some vectors within a document or your collection, and then you can get some semantic search results, which are basically results that share the same meaning with the input. So this is semantic search, and then you obviously get the similarity score as well. So these are the foundation of some of the stuff we had today when it comes to AI. And we're going to be looking at how vector search powers really, we're going to look at how vector search operates within two data solutions, but you can use vector search as a foundation for your semantic search application, Q&A system, and your agentic systems as well. So if for those of you who've heard about the term agentic RAG, this is the foundation technology that's powering it, vector search. On that note, let's talk about AI databases. And the term AI database is relatively, I guess, coming into popularity and what and doesn't have a concrete definition. But I see AI database as any data management solution that is trying to solve for the efficient storage and retrieval of data used within AI application. So these are structured, unstructured data, and also more popular today is vector data as well. So there's a lot of databases that are extending their functionality to handle vector data. And there are databases like MongoDB that gives you that native capability for vector search as well. So you could classify these databases as AI database. So what are the common AI database architectures that I see in the field? So you will see a split architecture where you have your typical operational database like MongoDB, which is your primary database. Then you have a secondary database that is used to host your vector data or hold your vector data and conduct vector search similarity. So this is what we call a split architecture. And it doesn't have to be just a vector database. You can actually have specialized databases like graph databases they just do graph traversal. So you can have those are what you can see as split architecture, where you have two different databases that are used for different data types. But the unified architecture actually takes the two functionalities, wraps it into one database. So you have one database that is actually providing you the functionalities to handle, retrieve, store, and efficiently handle different data types. And that's what we're going to be looking at today. We're going to see code for a split architecture with Elasticsearch and MongoDB. Then we're going to see the same thing in a unified architecture. And then we're going to look at when and why you would consider either one. But to just level set here, Elasticsearch, for those of you who are not familiar, is a very efficient search engine that also gives the ability to store and retrieve vector data. So it provides this search engine and that behind vector data. So you see Elasticsearch used with some operational database like we're going to see today. Then MongoDB is a modern database. Essentially, MongoDB is really designed from the ground up to handle the challenges that we're seeing today in AI application, while giving you some of the search mechanisms that you require for your AI application with the robust infrastructure and functionalities of a database system. So one thing that people also need to know is both Elasticsearch and MongoDB at the foundation, they share a common foundation, which is Lucene. So they share the foundation, which is the Lucene technology, the same high performance search library, right, that powers Elasticsearch, or search engine that powers Elasticsearch, also powers MongoDB. So you can begin to understand that you can get that Lucene, powerful Lucene capabilities you see in Elasticsearch. You can get that in MongoDB with all the important features of a database, such as ACID compliance and all the robust features within MongoDB Atlas as well. So just trying to give a common understanding that the Lucene Foundation helps both MongoDB and Elasticsearch. But when you select MongoDB, you're not compromising on that vector search capability, because under the hood, they're both leveraging the same technology. So what does that really look like when we're talking about split architecture. So you may see an operational database and a vector database, and you typically have like some form of ETL, or you have some data synchronization functionality to make sure that data between between the two databases are always in sync, and not one data is not out of date. We're going to be seeing examples of some of the challenges that we see people face whenever they're using a split architecture, and how we can solve this as well. Some of you might even be running into this problem today, or you run into it later if you're using that split architecture. What we really try to point out is the most important thing, regardless of database or what solution you're using, is developer productivity, right? Because we see that a lot of the key consideration when it comes to AI really depends on how fast developers can really build out solutions or build out features. So when you're actually using two databases or two different technologies with two different languages and infrastructure constraints and knowledge you have to know, you need to realize that there is a tax you have to pay, and also your developers have to probably do more work than they probably need to. So developer productivity really is the foundation of time to market for a lot of this AI applications and AI features, is one of the key drivers of this. And then you pay the sync tax. We're going to be seeing some of that as well. And there is some more operational overhead with the split architecture. But with a modern architecture like what MongoDB brings to the table, it really solves for some of the problems we're seeing today around data synchronization or operational overhead when you're using multiple systems, because we're consolidating all the search you need into one solution, all the storage features you need into one solution, and all of the advanced, efficient storage requirements, such as quantization, you need into one solution, and that is MongoDB. So you don't have to learn different query language, you don't have to learn different infrastructure. You just have to use one single database for your AI application. Even if you're trying to do graph traversal, MongoDB has the dollar graph lookup that allows you to traverse through document through via relationship. So we talk about the disadvantages of the split architecture. I'll also talk about the advantages of the unified architecture, which is you have this improved developer productivity. You have a simplified data architecture. You don't have to think about two. You're only thinking about one. And then you have a platform that is managed in one solution. And I want to touch on another topic, and I find it sometimes important to talk about this, because a lot of folks that are getting into the space today, RAG, agentic, are AI developers and not database administrators or database developers. You might not have a database background, but there is something called the ACID principle. And for you to use a database as your primary database, you actually have to make sure that your database actually hits or meets a bunch of requirements. And a database being ACID compliant is one of them. I'm going to explain what ACID is, but the importance of this is whenever you're building mission critical application and you want to ensure that there is data integrity, there is security, ACID principles comes into the conversation. So atomicity really points to the fact that any database transaction are either going to be successful together or they're going to fail together. So it's sort of like an all or nothing game. So there is no partial failure or partial success with any transaction. There is no maybe two fields got updated and the rest of the fields didn't get updated. Every transaction are either going to succeed together or fail together. And you are going to see an example of this when we get to the code section in about 5 minutes. So consistency means that whenever a transaction is made to the database, it always takes the database from one valid state to another, right? There is data integrity. There are constraints and triggers. There's data integrity when constraints and triggers are executed. So essentially, all the relationship between the, if you were to look at it from a vector perspective, all the relationship between the documents and the vectors are going to remain in the same state within transactions. So you're not going to get any sudden changes. Then concurrent with isolation, it means that every transaction is isolated and they wouldn't essentially interfere with each other. And when one transaction is committed, it will complete, then the next transaction is going to come into play. So it's sort of approaching a database transaction in the sort of sequential manner, where transactions are executing sequentially, even if they're concurrent. So durability. This means that all the changes in transactions you give into your database are actually going to be committed, they're stored, and they're going to be executed even if there is any failure outage. So these are the ACID principles. You can look into it. This is just a brief example of some of the key consideration that we see in the database world, but that might not be top consideration for AI developers, but it's important to be aware of, because when you're building your AI application, especially if you're building it for all of this critical industries that are highly regulated, where a data audit trail is important, and where there are also strict regulations. So we're talking about healthcare industry, finance industry, the legal industry. Some of this are very, very important. So whenever you hear someone saying, is a database ACID compliant, it just means that the database meets all the principles that we spoke about in the previous slide. Then ACID transaction essentially means that a database transaction is going to meet all the principles that we spoke about 2 slides ago. So those are the exciting bits of this demo, not the demo, the presentation. Now, I am going to share my screen and move over to the code section. And when we get through 2 parts of the code, I will share with you the link to where you can access this code, so you can actually follow along, or you can even try this in your own time. So if you bear with me 1 second, I am going to stop sharing, then reshare my screen. There's some questions as well. There's some questions as well that I'll be getting to as well very soon. So yeah, keep the questions coming. I'm going to try to answer as much as I can. So,
and real quick, once you start answering those questions, make sure you're clicking answer live when you do. And everyone, please make sure, just to reiterate, the recording will be shared later this week with you all, not the slides, so you can watch at your convenience.
Okay, here we go. And I'm sure you can all see some code right now. You can put a thumbs up in the chat if you can see some code. Let me just increase the screen. So, or plus sign, which is good. Okay, so we have this notebook, and I'm going to give you the link to this notebook on the chat in about 2 minutes, where you can just access this. So in this notebook, we're going to look at Elasticsearch and MongoDB vector search, and we're going to be looking at Elasticsearch. We covered what Elasticsearch is, we covered what MongoDB is as well. But we're going to be looking at this 2 technology within the split architecture, and looking at the unified architecture. So 2 ways that you can handle vector search and also all your AI application data requirements. So there are 6 parts to this notebook. It's quite informative, and there are some images as well from where the slides, are. So I see a lot of people asking for the slides. Some of them are also present in the notebook itself. So just to go over the slides, we're going to look at some data setup. This was in the RAG pipeline I showed you earlier, just how you ingest the data and embed the data using Voyage AI embedding models. Then we're going to see vector search with Elasticsearch. So if you're a Elastic user, you're going to learn how you can actually use vector search with Elastic. You can also have access to, you're also going to see how to conduct different search mechanisms with MongoDB. Then there's a part here that demonstrates MongoDB ACID capabilities, but also I'm going to focus on this data synchronization challenge, right, that we see with split architecture, and explain why you really want to be using MongoDB, because you get all the search capabilities as well as the ACID compliance. And then we'll finish off with some performance guidance. We're going to try and get through it relatively quickly, but really touch on the key points. So we spoke about AI databases, and that term is basically one that we use for any data solution that meets with the requirement for data management within AI applications. So, which in this case is the handling of vector data and also the efficient retrieval of vector data. In terms of our data setup, we're using a data set, a modified data set, which is the way of articles from Wikipedia. Is the Cohere data set, but we took a segment of it and we generated some embedding using the Voyage AI embedding models for it. So you can go to this data set and you can get some data for your POCs or for your experiment. So we take the data, do some data preparation, and we generate our embedding. Just going to scroll down really slowly. We generate our embedding using the Voyage 3 large embedding model. Now, this is a state-of-the-art embedding model that is very performant. And one thing about this model is that it is quantized aware, which means that if you reduce the precision data type of this model, it will still be performant. And those of you that are thinking, what is quantization? There's a notebook that we have that explains this within the Gen AI showcase, which I'm going to be showing you later. But key thing is, this is how we're generating embeddings. And the data set comes with embeddings already, so you don't need to generate any new embeddings. We're only going to be generating embeddings for the query we pass into as prompts. Okay, so those are the key things. We've seen the slide already, what is vector search, and we've seen what vector search is used for. Now let's get into the technologies that we're looking at today. I'm using a local version of both Elasticsearch and MongoDB as well. So I'm using the Atlas CLI to have a MongoDB data instance on my local machine. So for those of you who are interested in using MongoDB on your local, this notebook will give you a very good starting point. So I've kept as much instructions as possible for how you can install Elastic. And you can also get more links into some of the instructions that will guide you into installing Elastic and running it on your local machine. But I'm going to go through some of the key aspects of what we're doing here in Elastic. This is just connecting to my Elastic database. That's what I'm doing right here. But over here, to get straight into it, the name of the index I'm going to create is Wikipedia. So we know that Elastic gives us is an efficient search engine, right? And it gives us the ability to search over vector data. But to do that, to search through vector data, you need to have a vector search index. And we're going to be creating one using Elastic as well. So one thing I also want to point out is when you ingest data into vector data into Elastic, they actually get converted into 8 bits. So what that means is sometimes whenever you get data from OpenAI embeddings or your Voyage AI embeddings, they usually come in float 32. So that means there's 32 bits for each of the numerical representation of each element. But by default in Elasticsearch, this is actually changed and converted into 8 bits, which is a lower precision data type, and which basically it gives you some memory optimization benefits. So just pointing this out because it's not obvious to a lot of people, even to some folks that have used Elastic for a long time. This particular point is not obvious. This is why you see this feature here where I'm placing the index option as HNSW. This will retain the full fidelity vectors. But if you were to remove this, your vectors will get converted from float 32 to int 8 by default. And the thing is, MongoDB allows for this int 8 quantization, but you have to specify this. We don't make any assumption that you want to do this. We allow you to dictate this in the vector index, which we show in this notebook here as well. So that's a key thing for a lot of folks, that are working with vector search. So the rest of this is just setting up the index, and then I'm just going to do a batch insert of data. I've 1,000 data frame into Elastic. So here we're going to do the insertion, and you can see that we actually inserted 1,000 documents, and that's it. It's completed. Now, what can we do? What search mechanism does Elasticsearch provide us with? We have text search. So this is how you implement text search in Elastic. This is full text search. And here we can see we run the query, when was YouTube launched and by whom, and we run that through Elastic using the text search, and then we get this results, just 5 results. But you can also use Elastic for vector search. It provides you a vector search engine. And here you can see we do the same thing. We run a search query, particularly we're running a search query using the k-nearest neighbor algorithm, which is for the vector search operation. And now we run the same query, and now we get our results, which is basically retrieving results based on meaning, semantic meaning. So here you can see this is what you probably refer to as semantic search over here that is being powered by a vector search operation. And that's how you implement some of the common search mechanism we see in AI today in Elasticsearch. But you can do the exact same thing in MongoDB. So I take you through the steps again with MongoDB. Using a local installation of MongoDB using the Atlas CLI, you're able to, you get your Mongo URI that will look like this if you follow the instruction, and then you can connect to your MongoDB cluster on your local, you can connect to your MongoDB database in your local machine, and then you can retrieve, create a database, create your collection, and just like we did with Elastic. But here, we're going to be creating the index as well. So I'm just going to scroll a little bit quickly. Here you can see us, we're going to be creating the index, and the type of the index we're going to be creating is a vector index, and we're going to specify the path to where the embedding is located, the dimension of the embedding, and what distance function we want to use, distance measurement function we want to use as well. And if you wanted to activate quantization, all what you have to do is just put in the quantization attribute over here, and then specify the quantization method you want to use. In the case of int8, it will be scalar, but we're not doing that in this demo. We're going to use our full fidelity vector for both Elastic because we turned off the default quantization, and we're going to not use quantization in MongoDB Atlas, where you can if you want to. So through the step, we do the same thing, right? We have the search mechanism over here where we're creating a search index, and this allows us to actually perform a search operation using lexical, using keyword data. One thing to mention is I am transforming, and apologies for the scrolling, and there's loads of questions. I'm going to get to them very soon. I'll take a break to answer the question. But I am transforming the vector data into a BSON. So this is a bin vector data type that is a very efficient method of storing data and also retrieving data. So BSON is one of the key fundamental types within MongoDB database. So this is something that other database might have some replication of, but no one does it better than MongoDB does. So there is more on that in this notebook, so you can read more of it. But very quickly, once you convert your data into BSON, don't be alarmed if you see the binary representation of your embedding. This will still do your vector search operation. And now that we've got to the halfway mark, I'm going to share over here the code. I've shared in the chat where you can get access to this code that I am sharing with you. So those of you, you can go look at the code and follow along, because I'm about to go into some of the crucial bits over here. But at the same time, for those of you who are more interested in exploring more use cases of MongoDB, looking at how to build a agentic system, go to the next link I sent over, which is a GenAI showcase. This is a GitHub repository that has over 3,000 stars. It's very popular within the AI space. A lot of developers use this to get up-to-date knowledge for different use cases and application type. So when you're in that repository, feel free to leave a star and a watch or fork the repository. Engage with it in any way you want, and let me know if there's anything you'd like to see us do as well. So I'm going to go back and we're going to move a little bit quickly. So the same way we did text search and vector search with Elastic, you can do the exact same thing with MongoDB. So over here, we're running a text search function, and we have the same search query, and we get the results as well from the search operation, right? Now we do a vector search operation and we have the same thing. We create this vector search stage, and then the rest of it is trivial, which is a projection stage. And now we do the same query, and now we're doing semantic search, right? Because we're searching by meaning, searching by context. And here you go, you have vector search. The exact same process that you have in Elastic, you have in MongoDB, powered by the foundational Lucene technology as well. So, but this is where things kind of start to differ. With the asset capabilities of MongoDB, the asset compliancy of MongoDB is where you start to reconsider what do you want for your AI workload. So this is something that I show as well. And this is an extensive example of asset compliancy and how MongoDB meets this. But I'm going to skip this for today. I've given you the link so you can check it out. What I'm going to skip to is what we're talking about in the slide: a split architecture and the downsides of it. So here in part 3, what you've actually seen is that unified architecture where you have one database that can handle your vector search operation, your search operation, is asset compliance, and also you don't have to worry about data synchronization between vector data and your other operational data. So we're going to see some of the architecture that we see today. So I see a lot of folks using MongoDB with their vector databases. Now, after this webinar, you're going to realize that you can use MongoDB as your one database, right, to store your operational and your vector database. So this is what we're going to see, the split architecture. I give a lot of commentary, a lot of notes on what is happening. So this, you can spend, you're going to get a wealth of information from this anyway. So I'm going to go through some of the coding and highlight some of the key points, and then I will go through the Q&A after this. So this is a split architecture demo, and what this demo is going to do is when you run this demo, you're going to actually pass in your Mongo client that we created earlier, that's going to be your operational database. Then you're going to pass in your Elastic client, which is going to be your vector data store, and it's going to enable you to do vector search. And what's going to happen is we're going to create a database within MongoDB called AI app, and then we're going to create a collection called documents to hold our metadata. Then in Elastic, we're going to have a vector index called document vectors, and it's going to hold our vector data. Now, one thing that this code does is we go through the same step that we've seen before previously, and also we're overriding that default 8-bit quantization Elastic does. But I want you to notice that we're also keeping a reference to the document ID in MongoDB. So we need this to have a reference of a document to the vector component within Elastic. If you have any question, use the chat and use the Q&A section, and I'll get to it. So the first thing we're going to do is we're going to ingest documents. So that's the first step of this demo. We're going to ingest document into MongoDB, and I'm just using some basic scenario here where we have a title, content, and we have a metadata. We're also going to also have this attribute where we're able to see if a document is active or is not active. So this will determine if we want to, maybe within a search result, we want to use only documents that are active. Also capture the timestamps of when a document is created and updated. So this is just the metadata, operational data. Is this all written in Python? Yes, this code is written in Python. But in the GenAI showcase, we have examples in C#. We have examples in JavaScript on how to build AI applications. So check out the GenAI showcase as well. So here we're just going to insert the data into MongoDB. And this is a standard operation. So we're inserting metadata into MongoDB. But when we insert the metadata into MongoDB, we're going to then generate an embedding using the content. And we're going to store this embedding not in MongoDB, even though we could store it in MongoDB, but we're just going to, because we're showing the split architecture, we're going to store it in Elastic, because this is the common pattern that we see folks doing. So you store the vector data in Elastic because Elastic gives you that vector search engine. And now you have to store the document ID from MongoDB on Elastic to have that reference. Then you have your, then you have the embedding, you store the embedding here as well. Then I also do a content preview of what was of some of the content, but not the full content as well. And this is just in case you want to do some search query, text search query. Next, we insert that data into Elastic. So now we have MongoDB insertion. We have our operational data in MongoDB, which is our metadata, then we have our vector data in Elastic. Split architecture, 2 databases for 1 solution. But here is where you start to run into your first challenge. What if the insertion into Elastic fails? Right? So what happens then? That means that you have to have some form of rollback mechanism. So what I mean by is if you had an issue where you had Elasticsearch, where you had your MongoDB insertions that was successful, but for some reason there was maybe a network failure with when you're sending your request, and now the Elasticsearch insert didn't work. Now you have a data existing in one place and data that doesn't exist in one other. Now, of course, you can solve this, which I show you here. You can have a rollback mechanism, right? You can have a simple rollback mechanism when you delete the data from MongoDB because you have the ID. Then you could retry the whole process again. That is one of the challenges you will have. Here is a second challenge when you're updating document. So, for example, when you want to update document, which you're going to see in a lot of AI application, you're going to see a lot of let's imagine like a transcript, right? You want to search for a transcript. Sometimes users might change spelling mistakes in a transcript, or even change some of what was said in the transcript. This would mean you have to start doing a whole re-indexing and re-embed the transcript. And you might have new title, new content, or new metadata. So now you need to update the data in 2 different places. So now you have your MongoDB. Let's imagine you're taking a MongoDB ID to do a search, and now you're able to now update the attributes within this ID, within that document itself. So we can update the title, the new content, and the metadata. That's fine. So we update MongoDB first, and if there were no matched documents, we're going to say document not found. But now, if the content or title was updated, we actually need to update the embedding. So if the transcript was updated, you would need to update the embedding. So you need to go through this process of updating the embedding. So what you can see here is we're going to generate our new embedding, and then we're going to put that and override the previous embedding and pass in the new data as well. Now, what you're going to have here is a situation where you might have a synchronization challenge. So you might have a synchronization challenge. So this is a second challenge. If Elastic update fails, after the MongoDB update succeed, you have 2 databases that are out of sync. So this, just to put it into context, I've kept a bunch of information here that speaks more into this. Imagine if the transcript was updated, but the embedding wasn't updated. Now, in your AI system, when your user is trying to search by meaning, what you're going to have is outdated, or your AI retrieval is actually going to be poor, or the accuracy of your output is going to be poor because the context has changed in the transcript, but that's not updated in the embedding because there's been some failure situations from the actual update procedure. This is the data synchronization issues. And of course, you can solve this, but this means you have to write extra code as a developer. And developer productivity is really, really important in a space that moves very quickly like AI. So this is what I'm trying to show. Then there's a third problem, which you can see when you try to delete a document. So I'll just show you an example. And within this function, I want you to take note of this simulate Elasticsearch failure. So one thing I'm going to do is I'm going to simulate a situation where we send a delete command, but it deletes in just MongoDB and not in Elastic. And that way you have another 2 databases that are out of sync. So very quickly, here you're going to see we want to delete a specific MongoDB ID, but remember we have the ID within Elastic, so we can use the same ID to delete the record from Elastic as well. But here we delete it from MongoDB. That's all fine. And once we delete it from MongoDB, we move on to try and delete it from Elastic. But if you set this to true, we're going to simulate like an error. So we're going to then come out of this function by raising an exception, and we're never going to execute this part of the code. And what that means is now we have two databases that are out of sync. We actually have a ghost document where you have a document that exists in one database but doesn't exist in another. I've kept there's ways you can solve this as well. You can write more code to solve it, or use a message bus to actually send signals or commands to both of the database so they'll operate in parallel. But again, more infrastructure in your AI solution. And you don't want to be having two databases, because what you have is in MongoDB is you can do vector search efficiently. You can use all of your retrieval mechanism within one database without having to worry about data synchronization, and you have the robust features of an ACID compliant database. So that's why you would be using MongoDB in this unified architecture. So very quickly, I'm just going to scroll down very quickly and show you. You could just, this is a function to run the demo. It just goes through what I've said. And I'm going to go into the output. When you execute it, you're going to see something like this, where we see the traces of the actions that we're taking. And then we see that we're simulating a failure within the deletes. And we can see that the output of a ghost document, we have the document deleted from MongoDB, but it still exists in in Elastic. So those are some of the scenarios that I have seen a lot of folks. And you can switch Elasticsearch for any specialized vector database like Pinecone or Weaviate, right? Those are specialized vector databases. But when you have MongoDB within your AI stack, you don't need those solutions. You just need one solution to handle all of what you need. So this is where the performance guidance comes in. We've spoken about this. So that was all of what I have for you today in terms of code. I'm gonna go back into the slides, and I'm gonna go through some of the questions that's been put forward. So I'm gonna stop sharing. I'm gonna just reshare this. I'm gonna go back to the slide, and I'm gonna take some time to go through some of the questions and answer. So someone said, sorry if I missed this, but what happens? Why does the document still exist? So the document still exists because there could be an error within your operation when you're actually within your update operation or your delete operation, right? So you can imagine maybe there was a drop off within the network, or if you're operating with cloud databases, there could be an actual error that could be a programmatic error as well, or a network failure error. Either way, the point is you have two documents. You have one document existing in one database and one doesn't exist in another. And again, there are ways to solve this, but you're either writing extra code, or you're using another tool within your AI infrastructure. The whole point is within MongoDB, you have your operational data sitting alongside your vector data. So you don't need two databases. Someone asked, is embedding value stored within the MongoDB document that has the metadata? Yes, exactly. You've got it, right? The embedding value is stored within the document. It's stored alongside the document. So you can do vector search, you can do text search, all in one solution. Asking about the correct document. Okay. Hopefully you can. Do we get this written in TypeScript? This particular example is not written in TypeScript, but over in the MongoDB documentation and in the Gen AI showcase, you have a lot of material that shows you how to implement AI application using TypeScript. We even have full apps in the app folder, so check that out. You have full apps from one that is a music app. We have sentiment analysis application written in TypeScript as well.
Please go to the Q&A slide.
Excellent. Here we go. So what if I have content in several databases other than Mongo, what would be my option to utilize Atlas search abilities? Well, I just showed you you could use your option one. If you have content in several databases other than Mongo, you can use all the other search mechanisms you're using in that databases with Mongo. So text, vector search, even graph traversal or any of the search mechanisms you're thinking of using, MongoDB has it. So basically, you don't need to have two separate databases. You just need to have one. Was that a trick question? I don't know. Um, Okay, so what is the raw search speed comparison between Elastic and Mongo? I like the idea of avoiding syntax, but would like to know more about performance. So again, when it comes to performance and within databases, there are ways that you can make a database more performant, right? So the underlying technology between with Elastic and MongoDB are the same. They both use Lucene to search through. They'll both use Lucene to implement the indexes that they're using for vector search. So they're both the same, but MongoDB has more robust features that makes it more of a database. Elastic is a search engine. So those are some key difference. But the key thing which you got right is avoiding the syntax, right? You don't want the syntax. You don't want to reduce your developer productivity. You want to reduce your time to market. What are the different KNN options available in MongoDB apart from cosine? So we have dot product and we have Euclidean as well. So you can define, we have that defined in the MongoDB documentation, and those will be placed in your vector index in your distance variable, in your distance attribute, I believe is the attribute that you need to change. So for bulk insertion, how it handles the chunks, how much time ideally would it take to upload? So for bulk insertion, it's really quick, right? Both MongoDB and Elastic gives you capabilities. In fact, every database gives you capabilities to insert data in bulk. I was working with Postgres earlier, and there were about 4 different ways to insert data in bulk. Obviously, some are more performant than others, but the point is MongoDB is very efficient at insertion, and you can try it out for yourself in the notebook I've provided. Let's see. Where is the Voyage embedding generator hosted? So Voyage embeddings are hosted on different cloud providers. So you can check the Voyage documentation, and I might get that for you if you have a bit of time. But again, this is a question that we will answer in one of our future webinars. So any other webinars that are touching on multimodal or touching on chunking, you should attend that, and that will be answered there. Does MongoDB have reciprocal rank fusion? Yes, it does. So we have a notebook that actually shows you how to implement the reciprocal rank fusion in MongoDB in the GenAI showcase. I'm going to try and see if I can quickly pull it, and if I can just quickly get you what you guys need. I don't believe it's there actually. So, but we'll be uploading that later in a few hours. That shows you how you can actually implement reciprocal rank fusion, or hybrid, or have hybrid search in general. But for those of you who want something now, if you go over to this notebook, which is evaluating information retrieval techniques with MongoDB and LangChain, you can actually do hybrid search with MongoDB and LangChain. And LangChain obviously has a bunch of abstraction that makes things easily. And we show you how you can evaluate different search between different search mechanisms. So lexical, vector, hybrid, we evaluate them. And this is good to understand which search mechanism you could be using as well. So GenAI Showcase has a lot of information and code. So that will be the last question I'll be taking on today. Yeah, that'll be the last question. There's a bunch of questions, and some of them are overlapping as well. And I believe we've answered that as well. And also some of these questions will be answered if you go through the notebook as well. So thank you for your time, guys. And thank you for joining me today. And I'll see you in the next webinar.
Thank you, everyone, for joining today's webinar. Also, if you'd like to continue engagement with us, please drop your questions in the MongoDB community forum. Thank you, Richmond, so much for this content and going through this presentation and answering all the questions. Again, please keep a lookout in your email. Early next week, you will receive the recording to watch at your own convenience, along with some additional resources that was shared in the chat today. Thank you all again, and I hope you have a great rest of your day.